Alright, so we're going to talk about radicals and rational exponents. We're going to go into adding, subtracting, and multiplying these. So with this, add and subtract radical expressions. As it says here, just as we can add and subtract like terms such as 3x plus 5x will equal 8x, we can add and subtract like radicals, such as 4 square root of 3 plus 6 square root of 3. In other words, a square root of 3 takes the place of like an x. Okay, so we're going to go forward and see how that plays out. So definition, like radicals have the same index and the same radicand. So examples of like radicals is in A here we have square root of x and 3 square root of x. So those are like because they both have just a square root of x. In B we have the 4th root of 7 and 8 4th root of 7. They both have 4th root of 7. And in C you have 3 square root of a squared b to the 7th and 10 times square root of a squared times b to the 7th. They both have the same radicals. So these next ones have radicals that are not the same. Okay? So as you can see here in part A, you have square root of x, and then you have 3 times square root of 2x. Well, square root of x and square root of 2x can be totally different altogether. In part B here, we have the 4th root of 7 and 8 times the cubed root of 7. Now granted, 7s are both the same, but the 4th root of 7 and the cubed root of 7 are totally different, so they're not like at all. And for C, we have 3 times the square root of 2 times a squared times b to the 7th, and 10 times the square root of a squared times b to the 7th. So with this, yes, we have a squared b to the 7th. However, there is a 2 times in the first set of thirds, so those are not like radicals at all. So the property of adding and subtracting radicals. In order to add or subtract radicals, they must be like radicals. Again, the key thing here is like radicals, okay? So like radicals all together. We add and subtract like radicals in the same way we add and subtract like terms, and so add or subtract the coefficients of the radicals and multiply the result by the radical. So in other words, we can add the understood 1 here, so we can take a 1 plus a 3, so that is our coefficient, and then we're going to, when we do that, it gives us 4, and we multiply it times the radical, okay? Which in that case is square root of x. So don't let the wording confuse you. We'll go over some more examples. So we're using the distributive property when we combine like terms in this way. So let's do some examples here. We got 9x plus 2x, okay? So we have these, so they can be added because they got the same. We just have an x there, right? So like we've done in the past many times, we can take this out and say it's simply 9 plus 2 times x, and simplify it. It can be 11x. Or we can just add them. Add the coefficients, right? Because we know the x's can be added like that. So you can take the 9 plus 2, which simply gives 11x. Alright, so first notice that these are like radicals. They have the same index and the same radicand. Therefore, they can be added. So on B here, we have again 9 square root of 5 plus 2 square root of 5. So for part B here, again, we have the same radical. So they're like radicals. Okay? So the same thing as if we had above there. We had a 9x plus 2x. It's very similar. So I guess we'll take 9 plus 2 times the square root of 5. Let's simplify that. It gives 11 square root of 5. In part C, we have the 4th root of 3 plus 3 times the 4th root of 3. So again, that fourth root of 3 is the same radical. We can simply take 1 plus 3, which will give us 4. So 4 times the fourth root of 3. In part D here, there's a little trick there, right? They're different. In which case we have our square root of 5 and square root of 4. Well, those aren't the same values, so therefore we cannot combine these two. You cannot take those. That is already in the simplest form right there. That would be your answer overall. Okay, so let's do this. Now, when you have this problem right here, let's go forward and see how we can combine this and make this work. So, there are two different types of radicals, so let's write the like radicals together. So let's put the square root of y's together and the cube root of y together. So I just rewrote the problem right there. It's the same problem I have above there, as you can see. Nothing's changed yet. Now let's put them together. So in this case, now we have our square root of y, square root of y, and we have our cube root of y, our cube root of y. Alright, so now they're all together. We can see we have a 9 minus a 3, and then we have a 2 plus a 2. So 9 minus 3, 2 plus 2, just like I just mentioned. So that will give us 9 minus 3 gives us 6 square root of y plus 4 cube root of 3. Well, that 4 cube root of 3 comes from 2 plus 2. So then we ask ourselves, is that in the simplest form? In this case, the radicals are not like the radicals are not like radicals since they have different indices. Because we have a square root of y and a cube root of y. So they cannot be combined any further. Also, you can't do anything else within the radical because square root of y, we have no idea what y is, so we can't simplify that any further. Same thing with the cube root of y. So simplify before adding and subtracting. So radicals sometimes look as if they cannot be added or subtracted. It is important to check to see if the radicals can be simplified. Sometimes by simplifying the radicals, they turn out to be like radicals. Then we can add or subtract. So again, a procedure: write each radical expression in the simplest form. Then combine like radicals. So let's look at an example. Form the operations and we'll simplify this. So we have 3 square root of 20 plus 2 square root of 12 plus 6 square root of 5. So to move forward with this, these radicals, are they in the simplest form? I don't believe so. The last radical is in the simplest form, but as far as square root of 5 is talking about, however, the 3 square root of 20 and the 2 square root of 12 should be simplified to determine whether the radicals can be combined. So if we move forward doing this, we can factor them out. Okay, so you can do this by simplifying like that, or you can do the factor tree, in which case, this way they've wrote out, we have 3 square root of 4 times 5 plus 2 times square root of 4 times 3 plus 6 square root of 5. Okay, so then you can break it into the product rule as they've listed out there. And this should be a little bit easier to see as far as actually doing the factor tree, right? Because if you're to take the square root of 4, simply 2, because you have to take, if you're to do this, square root of 4, that's 2 times 2, so you can take out a 2, which they did. So you got your 2 right there. And then take out a 2 right here. Okay, so now let's see what we do further. So now we can multiply these values. So I have 6 square root of 5 plus 4 square root of 3 plus 6 square root of 5. Now we're in the simplest form in our radicals, so therefore now we can combine our coefficients. So we can add these like radicals. So where we have a 6 plus 6, which gives us 12 square root of 5, and there's nothing else to add to the square root of 3, So that'll just be 4 square root of 3. Alright, another example here. So let's look at this. So A and B here. So on A, we got 4 square root of 50n minus 6 times square root of 2n. Okay, so let's put these in the simplest form, right? So 2n is simplified, however 50n is not. So let's simplify it. So again, we can factor it out just like I said. We simply take, to get 50, 2 times 25, and then the 2n was already simplified. So when you do the product rule, again, we can break that square root into 25 and over the 2n, and if you do that, do the factor tree and you break it out like that, square root of 25 is 5 times 5. So therefore, you can take a 5 out of that. So we should get 4 times 5 times square root of 2n minus 6 times square root of 2n. And therefore, that's where we got the 5. So the 5 is right here. So now let's multiply. So we should get 20 square root of 2n minus 6 square root of 2n. And let's subtract those coefficients. And therefore, we should get 20 minus 6 gives us 14 square root of 2n. Alright, in B, in these radicals, we have a cube root of x cubed y plus cube root of y. So we can simplify this because if we use our product rule and symbol of factoring with this cube root, we can actually simplify that a little further. So there's the problem again, same problem I wrote down. So let's break that up. In which case we're taking cube root of x cubed times the cube root of y plus cube root of y. You can simplify this, in which case the cube root of x cubed is just x. So if you remember this as well, this is the cube root of x cubed is the same thing as saying x cubed times 1 over 3. Well, if you multiply your exponents, that will give you x is 3 over 3, which is x to the 1 power, which gives us this guy right there. Because remember, take this cube root, that is 1/3, because there is an understood 1 over here. So 1 over 3. Okay? So that is where I got the 1/3, which that simplifies down to give me an x. So now we can add like radicals. So we should get x cube root of y plus cube root of y. And therefore, you can simplify this a little bit because there's an understood 1 in front of this guy. It's understood 1 right there. So you can simply take this and say x plus 1 times the cube root of y. Alright, so now let's multiply these through and simplify these. We have 3 times the square root of y plus square root of 63. So let's simplify. Square root of 7 we can't, but of course square root of 63 we can. So we'll factor it out. So we can look at this and say 9 times 7 gives us 63. Now we're going to use the product rule on that. And again, we can take this, and again that square root of 9, you guys should see as well. Square root of 9. This will give you 3 times 3 if you like to do the factor tree. So we should be able to pull out a 3 for the 9. So we have a 3 right there. Deal with multiplying n times the square root of 7. So now we can add the like radicals in parentheses. Okay. So we should get 1. There's an understood 1 in front of the square root of 7 here. And we have a 3. So 1 plus 3 should give us a 4. In which case it did. It gave us 3 times 4 square root of 7. So a 4 came from. And therefore 3 times 4 gives us 12. So 12 square root of 7. For B, on this, the square root of 6 nor square root of 5 can be simplified. So let's just do the distributive property and multiply the square root of 3 inside. So if we do that, again, we're going to distribute this inside the parentheses. So you get square root of 3 times square root of 6 plus square root of 3 times square root of 5. So we can simply say square root of 18 plus the square root of 15. Well, we can simplify that down a little bit here, it looks like, because 18 can be broken using the product rule of 9 times 2. So therefore, that 9, as we did above, should give us a 3. After we broke that down. So we should get 3 square root of 2 plus square root of 15. So again, this 9, square root of 9 gives us the 3 there. We have square root of 2 plus square root of 15. Since square root of 15 can't be simplified any further, we can't do anything. We can't add these two any further than this because they're not like radicals. Square root of 2 and square root of 15 are completely different. Okay, so same thing here. Let's do another one with multiplying and simplifying. Okay, so we got square root of m times, in parentheses, 3 square root of m plus square root of 18n. Okay, so we've got different radicals inside the parentheses for sure to start out with. And with that, our square root of 18n, that can be simplified. So there's our problem. Let's go ahead and factor this out. So again, we can take that as square root of 9 times 2n. So as we've talked about in previous problems, square root of 9, this should give us a 3 that we can pull out of there. In which case, as we just did the product rule, to separate the square root of 9 from that. So that should give us a 3, in which case it did. So that gives us a 3 right here. So now, we should, can we add those values inside parentheses? No, because they're not like radicals. So let's go ahead and we'll probably go ahead and just distribute that square root of m inside the parentheses. In which case we did. Square root of m times those two values inside parentheses. And let's simplify this. So now, if you look at this, again, you have m times m, which is m squared. We have a 3 in front of that, so 3 times the square root of m squared. And that should be a big red flag right there, because there is an understood 2 here, right? Understood 2 right there. So we should be able to simplify that by saying this is equal to m squared times m squared times the 1/2 in our exponents. And if you take 2 times 1/2, that's simply going to give you m to the power of 2 over 2, which is m to the power of 1. So that should give us a simplified of a 3m plus 3 square root of mn, because there's nothing else we can do with a square root of 2mn. Okay, in which case it is. So that is where we got this simplified down to 3m, because that can be broken down by taking the square root of m squared. You can also think of this as, if you're going to look at this, m squared, right? It's a square root, so you have 2 of the same. We take m times m to get m squared, right? We have 2 of the same So in other words, you can pull out one of them. So therefore, you should get an M. Either way you look at it, that's how it should play out with that style of format. Alright, so let's look at another example here. So we're going to multiply now. So really this is FOIL, right? First, outer, inner, last. You guys are pretty understanding of the FOIL method. We've done it multiple times, so we can multiply these binomials containing the radicals in the same way. Okay, so we're going to take this problem right here, we have for A, and use the FOIL method for this. So again, first, outer, inner, last. So if you look at this and simply go with your first, 3 times 6, outer, 3 times square root of 3, then your inner, square root of 3 times 6, and then the square root of 3 times square root of 3. Okay, so now we just need to go ahead and simplify this, multiply these values out. So 3 times 6 gives us 18. You can't do anything with 3 square root of 3, nor the 6 square root of 3. And we have plus square root of 9. Well, again, as we've seen square root of 9 multiple times, we should understand square root of 9 should give us a 3, because it takes 3 plus 3 to get that. So therefore, square root of 9 should give us a 3. And it does. It gives us this 3 right here. Go ahead and write that out. And now we can combine like terms. So we should get 18 plus 3 gives us 21. And then you have 3 square root of 3 plus 6 square root of 3. We can add those coefficients, and 3 plus 6. And that'll keep the same radical. So 3 plus 6 is 9 times our square root of 3. Okay. So we can do the same thing here on this example. So we're going to go ahead and write out this problem using the FOIL method. Again, first, taking 4 square root of 2 times 2 square root of 2. Then you're going to take 4 square root of 2 times the negative 2 square root of 5. And then you take the inner square root of 5 times 2 square root of 2. And the square root of 5 times negative 2 square root of 2. And there we have it written out just like that. First, outer, inner, last. Okay? So now let's go ahead and multiply those out together. You only have 4 times 2, which gives us our 8 right there. So 4 times 2 is 8. We have a negative 4 times the 2, which gives us a negative 8. Then we have an understood 1 times 2, which gives us our 2. And then we have a understood negative 1 times 2 is negative 2. And then we just multiplied the radicals as well. So again, we have square root of 2 gives square root of 4. In this first part, 8 square root of 4. Then we had a 2 and a 5, so that gives us square root of 10. Same thing on the next part. And then we had the square root of 5 times square root of 5 in the last, which gives square root of 25. Now hopefully you can see automatically there, right? It's dealing with the 4 and the 25. 2 times 2 to get 4. 5 times 5 to get 25. So that should be simplified out to be able to get a 2 for the square root of 4 and a 5 for the square root of 5. I mean, it's 5 for the square root of 25. Because that's those values simplified down to. So now we can combine those, multiply those together. So we should get, with this, we got 8 times 2, which is 16. And then we got a negative 10. So 16 minus 10 gave us our 6. And then we had a negative 8 plus 2, which was negative 6 square root of 10. Okay? So that's our overall answer for that one. Alright, so let's do this one. So we can use FOIL, right, to square binomial, or we can use these special formulas. So you can do this if you have a formula or a problem like this, as far as saying the square root of 5 plus 2, and all that is squared. So since we have the plus, we use the top value there. We're saying a squared plus 2ab plus b squared. Again, as your a and b written out just like that. So our a in this case, for this problem, is going to be square root of 5, and our b is going to equal 2 in this problem. Okay, so if we have that, then we can write this out exactly like it is. So again, it says substitute the square root of 5 for a, like we said, and a 2 for b. When you put those values in there, we can go forward with simplifying this now. Now again, we have square root of 5 squared, so that should allow that square root to go away. Okay? We should be able to multiply the 2 times 2 here. So you get a 4 square root of 5, and then 2 squared is simply 4. So multiply together, exactly what we got. Again, that square root of 5, if you have it something like this, where it's all square, it's the same thing as saying 5 to the 1/2, all that's squared. Well, when you multiply radicals, exponents, multiplying exponents, that was going to give me a 5 to the power of 2 over 2, which is simply 5. And that's how we got this 5 right here. And then, as I said, we have 4 square root of 5 plus 4. So let's combine like terms. 5 plus 4 is 9. And then we still have our 4 square root of 5, and that's simplified as far as you can go. Okay, let's do this one right here. Now multiply and simplify. So again, this looks somewhat similar, but again, you gotta look at this. You got a plus and a minus. Okay, so don't let that get you. Let me put more than just a little dash there so it doesn't look. I got a minus and a plus. Okay, looks similar, but they're not. So with that, we can use this equation, a plus b times a minus b, is a squared minus b squared, and simply use our 2 times the square root of x for our a and square root of y for our b. So if we do that, and substitute just as I had mentioned, and if we take those and use your square each term, so you get 2 squared times x minus y. And remove the parentheses because it's not needed, because nothing else you can do inside the parentheses for the x. So 4x minus y, and that's it. So when we multiply expressions of the form a plus b times a minus b containing square roots, the radicals are eliminated. This will always be true. So if you are presented with that type of setup, it should work out just like that. Now again, if you don't remember that rule, you can do the FOIL method just as we talked about, and it'll still work out the same. Of course, it'll be a little bit longer process if you don't know the little trick, to that being equaling a squared minus b squared. However, you will still come up with the same exact answer. Alright guys, so I hope you learned a little bit of something today, and I'll see you next time.